Okay, practice test for sections 5.1 to 5.3. The beginning of the unit that we started with chapter 5 was just about, can you get it in standard form? Can you give us the names that it would be called? So it says write each polynomial in standard form, classify it by degree and by number of terms, and then describe the end behavior. So let's take a peek. We've got negative 3x to the third plus 4x cubed minus 1 minus 5x squared. Is that in standard form? What's wrong with it? If you said it's not in standard form, why not? Well, the negative 1 should be in the back. Can we do anything else with it? Yeah, we do have like terms. So negative 3x cubed plus 4x cubed would give us 1x cubed. Yeah, this is not the best, is it? So maybe look at your paper instead of trying to see what's going on up here. Alrighty, classify by degree. What is the degree? Look at your paper. Don't try and look at this one up here. 3, it's a cubic. Number of terms. Trinomial, but this one had 4. Yeah, you have to have it in standard form first, so don't forget that. This is a trinomial. Now, as we went through further and further into 5.1, then they started talking about end behavior. So we're supposed to look at this and say, it's a cubic, and it has a positive in front of it. Cubics with a positive in front have that S curve. So as we go to the left forever, where's this graph going? Down, negative infinity. Remember, it's like starting here in the middle and saying, if I were to draw this going to the left, where's it going? And that's going down, and that's negative infinity. So how about if you went to the right? Where would you be going? Yeah, positive infinity, right up here. Positive infinity. So that piece, you could, we're not taking the graphing calculators away from you. You could graph this on your graphing calculator to see the end behavior too, but you have to know that down is negative infinity and up is positive infinity. That's not that big a deal. Alrighty, next one. 2x to the fourth plus 21x plus x squared. Is that in standard form? No. 2x to the fourth plus x squared plus 21x, highest power. Working our way on down. What would it be called? By degree. Quartic. Quartic. Number of terms? Trinomial. What's up, John? Oh, no, you're taking that farther. You're trying to find the zeros. Standard form is just put them in the right order. That's all it is. Combine any like terms and put them in the right order. All right, it had 3 terms in standard form, so it's going to be a trinomial. Now, 2x to the fourth. What do those look like? Yeah, big parabola. Is this one going to go up or down? Going to go up because it has a positive in the front. So what are we going to put for both of those? Yeah, positive infinity. There we go. Got it. Positive infinity. So are the names coming back to you? Okay, so degree 1 is linear. Degree 2, quadratic. Degree 3, degree 4, 5. And that's as far as we would go. The quintic there. So have to remember those names. I don't think monomial and binomial and trinomial is going to throw anybody, you know. What if it has 5 terms? Polynomial of 5 terms. Yeah, that's, you know, and that's what we do with 4 as well. Alrighty, 3 says find the relative max and min of y equals 1/2 x to the third minus 2x minus 2. Is that something we can do by hand? No. We have to use the graphing calculator. So grab the graphing calculator. go to y equals, and we need parentheses, 1 divided by 2, parentheses, x to the third minus 2x minus 2. That's all in that y equals. You ready? So let's try zoom 6. Let's see if we can see the highest and the lowest points with zoom 6. Okay, so everything with technology is going to give me issues today? It's locked up. Look at those little beads over there. Just unplug everything. That's what I should do. Unplug everything. Go back to the whiteboard. Well, they have to earn that, see. That's different. My integrity does not allow me to think of such things. Oh, good. Now it's not totally on. Y equals graph. There we go. Just needed a little time. Time to itself. It was taking a break. Where do we get it to find that? Where are the buttons here? Second trace. Maximum number 4. Blinky to the left side of the hill. Press enter. Move Blinky to the right side of the hill. Press enter. Enter to guess, because we don't want to take a guess. And there it is. And it doesn't say, but we have to go at least 2 decimal places. We have to go at least hundredths. So negative 1.15, comma, negative 0.46. There's our max. Then we need the minimum. So second trace, number 3, minimum. Blinky needs to be on the left side of the valley. Press enter. Right side of the valley. Press enter. Enter to guess. 1.15, comma, negative 3.54, rounding. And we'll do that on the test too. If it doesn't say round to the nearest blah blah blah, we'll just do hundreds. So I'll try to remind you about that tomorrow, but we'll just do it the same as we do on the practice test. We done with that one? Yeah, that's the only max and min, and that's all calculator. I'll turn it over to the calculator and let it do it. Alrighty, now this says we've got to write a polynomial function with rational coefficients so that p of x equals 0 has the given roots. So these are the answers they got. We have to work backwards to get the whole polynomial. And we need to remember that each of those factors came out of x minus a. So, if it's a polynomial function, it's going to need a fancy function name like f of x. How did they get a 3? What did the parentheses look like if they got a 3? What did they look like if they got a minus 3? How about with a 1? X minus 1. Now, I don't know about you, but I saw those first two and went, woohoo! I'd multiply those together first. Those are nice. That's a sum and difference pattern. That's just going to give us 2 terms. So I would group these 2 together first and get x squared minus 9. Do the easy stuff first. And then it's just FOIL after that. So first times first. Outside times outside. No, I'm not saying it out loud because I want you to do it and then check it. Inside times inside. Last times last. We good? All right, let's write it down over here as best we can in this little line, but I write too big, so I don't know that I'll be able to fit it. X cubed minus x squared minus 9x plus 9. Yeah, my x squared is not readable. Whenever I try to write small on the smartboard, things do not go well. That's a little better. Okay with that one? Okay, let's go to number 5. Oh, it's a toughie. Something's bothering me. I think there's something we were supposed to remember about if the square root of 2 and imaginaries were there. Oh, the negatives have to be there also. Exactly. So they're going to give us these, but we have to know that's not all of them. We have to remember that. Imaginaries and nasty roots always come in pairs. Remember, that's part of that quadratic formula, plus or minus piece. So I'm going to call this one g of x just to be different. No f of x. So that would make it x plus the square root of 2, x minus the square root of 2, x plus 3i, and x minus 3i. Can you give me any tips on the grouping that might make this go faster? Yeah, put the ones that are, I guess you'd say, kind of alike together first. So put these two together and these two together. That'll get rid of the goofy stuff. You know, no more square roots and no more imaginaries if you do that. So in the front here, first times first, x squared. Don't have to do outside times outside and inside times inside because one has a plus and one has a minus, and when that happens, the middle term drops out. And then I'd have minus the square root of 4, but the light bulb would come on. Oh, that's a 2. Now, do I know that some of you are capable of going from this step to this step? Yes, I know that. But on the test, you're not going to do that. Because remember, every step is worth a point. So you're going to show all the steps as you go through it. This little bugger back here, first times first will be x squared. Won't have to do outside times outside and inside times inside because they'd cancel out. Minus 9i squared. Light bulb moment. What's the light bulb moment? I squared is -1. Oh, let me write that in a different color, so if somebody looks at this later, they'll pop out at them. So that'll become x squared plus 9. Oh, this just got so much easier. Now all we have to do is FOIL. That's it. And we'll have a nice little polynomial. First times first. Outside times outside. Inside times inside. Last times last. Put them together and take a peek up and see if you have the same thing I have. Looking good? Okay, so the key to this one is remembering any goofy radicals and any imaginaries come in pairs. If you can remember that, it looks like everybody's going to be just fine. I don't think you needed me a whole lot for the multiplying piece there. Feeling okay about that one? All right. Find the zeros of each function. State the multiplicity of any of the multiple zeros. Well, it's already factored for us. How helpful is that? Negative x out in front, what is it? It is 0, even if there's a negative, right? Negative x equals 0, you divide both sides by, well, in fact, let me write it down in case somebody's thinking, well, isn't that going to change it? No, it's not going to change it. It's still going to be 0. So 0, 0, multiplicity of 1. This little power of 1 if it's not there. Now, technically, we talked about this too. We don't write multiplicity of 1 when it's only there once, but you might want to do that just so you don't forget to do it on the next two. X minus 3 equals 5. What's our 0? So that'll be 3, 0. Multiplicity of 5. Power is 5. Last one, we'd probably want to do a little bit of work. Set it equal to 0. Oh yeah, I'm going to add 5. And then I'm going to have to divide by 2. Multiplicity of 2. So, yeah. Oh, you don't have to write out the word multiplicity. No, lowercase m stands for multiplicity. So, yeah, I don't know if everybody heard Simon. He said, should we write out 0, 0, multiplicity, the whole word, 1, multiplicity, 5? No, the little m, that's our math short way to write it, multiplicity. Now, if you were going to check this is kind of a tough one to check. But what you can do is you can punch this into your calculator and make sure it crosses at 0, 0, because odd multiplicities cross, crosses at 3, 0, and bounces at 2.5, 0. That would really be the only way to kind of check this with the graphing calculator. Alrighty, so now test-taking strategy. That one was all factored for us, and we found the zeros. So what are they going to do? They're going to take that factoring away from us and make us do it. And that's what we're doing here. So this is, hey, let's find the real and or the imaginary solutions of each equation by factoring. Remembering that we might have to maybe complete the square or do the quadratic formula for the ones that are imaginary. So take a look at 7. Thoughts? Take out an x. It's already equal to 0, so that's great. But we need an x out of there. Okay. Perfect square trinomial? No, that's a -4 in the back. Do we know two numbers that would multiply to -4 and add to 3? Yeah, +4 and -1. Oh, well, that one wasn't bad. What's our 0? 0. How about that one? So we'd have 0, 0, -4, 0, and 1, 0. Those would be our 3 zeros. Now, you could punch this into the calculator, make sure it crosses at 0, 0, -4, 0, and 1, 0, and then you'll be good. Yeah. No, I think in the past, the other thing we've taken is some students write x equals 0, x equals -4, x equals 1. That's okay too. This would be best because this is telling us the points where it crosses. But yeah, you can write it that way. Number 8. Is that scary? Shouldn't be scary. Special, isn't it? Cubes. Yeah, cubes. This is x cubed. What do you cube to get 27? 3. Alright, so we have to remember our little formula. A cubed plus b cubed equals... Which is it? Minus, plus? If this is plus, the first binomial is plus. It matches. Okay, then we know we need the a squared and the b squared, right? Because that's going to get us, if we multiply it back together, a cubed and b cubed. But that would have a middle term. How do we get rid of it? Minus ab. There we go. So this is a, and this is b. X plus 3, x squared minus 3x plus 9 equals 0. Ooh, we got a good start. In fact, we got 1 0 that's just begging us to write it down. What's that? -3, 0. Now, we've talked about this before. 98% of the time, that other one is not going to be factorable. X squared minus 3x plus 9. Well, it's not a perfect square trinomial because the middle term doesn't fit. Because we need x times 3 doubled. It'd have to be 6x, and it's not. Two numbers that multiply to 9 and add to negative 3. Not happening, right? Now, completing the square or quadratic formula. Completing the square with this one will have fractions. They won't be horrible fractions, but it would have fractions. So if you're fraction phobic, you're going to want to do the quadratic formula with this. And x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So it will be x equals the negative of negative 3, which is 3, plus or minus the square root of negative 3 squared is 9, minus 4 times 1 times 9, all over 2 times 1, which is 2. And then I suppose grab a calculator if you're not feeling good about the math that's taking place under that radical there, huh? 9 minus parentheses, 4 times 1 times 9, parentheses, a negative 27. What does that tell us about our answers? Imaginary, yeah. We've got a negative underneath there. So let's figure out what we can do with the square root of negative 27. Obviously, square root of negative 1, right? You got any perfect squares that will go into 27 nicely? 9. 3 times. So this will be 3 square roots of 3i. So let's replace that. Can we simplify that at all? 3's on top, 2's on bottom. No, we can't divide that out nicely. It's done. Now, did we get all the answers? We had one nice one, right? And then we've got these two buggers right here. And this is the reason, like I said before, some people will just write x equals for their answers because of ugly stuff like this. So, back up here. 3 plus or minus 3 square roots of 3i over 2, 0. You know? So like I said, that's why some people just write x equals negative 3, x equals 3 plus or minus 3 square roots of 3i all over 2. One nice answer, two ugly answers. But we got them all. That's what was supposed to happen there. All right, did I fit anything else down here? Nope. Next up, oh my, look at number 9. If this is equal to 0, that's good. Pull an x out? No, can't do that. Has 4 terms. Try grouping. Alright, so in the front, we could take an x squared. Definitely could do that. How about in the back? A 3. Oh, good. Because we have to see that x minus 2 is a factor. Remember, that's us tricking our brain into seeing that. So x minus 2 is a factor. And the leftovers were the x squared plus 3. All right. Nice 0 from this one. Where is it? 2. This one going to take a little work because it's not factorable. So what do? Subtract 3. Square rooty toot toot. X equals plus or minus. Ooh, how are we going to write that? Square root of 3i. So we did have a nice one. Pardon me. And then we have plus or minus the square root of 3i. 0. Like so. So we didn't have to use the quadratic formula. I mean, that was kind of nice. There it is. Alrighty. 10. What do you see? Looks good. Start factoring. What's wrong with it? Gotta move the 81 over. Negative 81, we'd have to add 81 to both sides. Ooh, but this might be a perfect square trinomial. X squared times 9 is 9x squared. If you double 9x squared, do you get 18? It is. I just need to know what goes in between those two. Yep, got a middle term that's negative. Hey, wait a second. That's a difference of 2 squares. We can factor that again. What does x squared minus 9 factor into? X plus 3 and x minus 3. So what are our zeros? Negative 3 and 3. So negative 3, 0 and 3, 0. Oh no, they can't be. How many answers is this supposed to have? It's supposed to have 4. Where's the other ones? Each of those were multiplicity 2 because they were there twice. They had that power of 2. So those are the only zeros. And if we graph this, we're going to see that it bounces off at negative 3, 0 and 3, 0. And we'll know, yeah, we're okay. Those are the only ones we have. So if there is a different way to factor this as well, because some of you might have said, I wouldn't notice this is a perfect square trinomial. I just would have gone through it and had x squared minus 9 times x squared minus 9 and made that x plus 3, x minus 3, x plus 3, x minus 3. Do you see in the end you'd get the exact same answers we just got? Yeah, so it'd be there twice, and you would see each of those is multiplicity 2, so they count for 2 zeros. 2 plus 2 is 4. Got them all. They're there. Using a graphing calculator to find the real solutions of the equation, where necessary, round to the nearest hundredth. Yeah, that's why on the one that didn't tell us what to round to, I said, let's round to hundredths, because then it'll be consistent. So can we slap this one in the calculator? Is it ready to go? Yep, it has a 0 on one side. So if it doesn't have a 0, you got to get a 0. X to the third minus 4x squared minus 7x plus 10. Zoom 6. Oh, they only gave us 1 slot. Well, yeah, we're not going to put 3 slots up there. We want you to tell us whether or not it's got 1 or 2 or 3 or whatever it has. So second trace and number 2. So Blinky is going to have to be to the left and below. Enter. Right and above. Enter and enter through guess. Negative 2, 0. That's the first one that we get. Second trace, number 2. But for the middle one, Blinky's going to have to be to the left is above the x-axis. And then hit enter. Below and to the right, enter. Enter through guess. Ooh, that's a nice one too. One more. Second trace, number 2. Blinky's going to have to be below it to be to the left. Come on, Blinkster. There he comes. Enter. Above it and to the right, enter. And enter through guess. 5, 0. So really, we could have gone second table on this one. This really worked out a little too nice. We would just use the table and we would have been able to get all of those zeros. I wouldn't count on that on the test. You know, since it says use a graphing calculator, usually they're going to be kind of nasty. Alrighty. Any of that, if you want me to go back to. Maybe make up another example of or something. Okay. So I'm going to give you a review packet, but we're going to scratch a couple of problems off because they don't work out nice. And as you just saw, stuff that's on the tests is going to work out nice. So